In a geometric sequence, it is a little bit different. I mean, I still have variables here appearing in my terms, but instead of taking the common difference, what I'm going to be doing is taking the common ratio. And I know the common ratio has to be the same for successive terms. So what does that mean? Let's take a look here. This is my first term, so this is my T1, here's my T2, here is my T3. So T2, T1, T3. Because I'm told it's a geometric sequence, I know that x plus 4 over x minus 12 will be the same as 4x minus 8 over x plus 4. So all I'm doing is taking the ratio of successive terms, and I know that they have to be equal. Now, if I cross multiply with this equation here, what I end up with is, let's see, x plus 4 squared, because I'm multiplying it by that one. Then I have x minus 12 times 4x minus 8. Well, let me expand, collect like terms, simplify all this stuff. There's my left side. And my right side becomes, let's see here, 4x squared minus 8x. 12 times 4 is going to be 48, but it'll be negative. So negative 48x. And finally, 12 times 8 will give me 96. I can simplify this right-hand side. Minus 56x plus 96. And this equals x squared plus 8x plus 16. So what does that mean then? If I bring everything over to, let's bring everything over to the right-hand side, I end up with a 0 on here, 3x squared minus 64, and then I have a plus 80. And I have a quadratic equation. So if I want to solve for x, nothing is easier than using the quadratic formula, which is what I'm going to do next. So here's my equation. Let me plug it into the quadratic formula. I'll do that over here. Recall negative b plus or minus the square root of b squared minus 4ac all over 2a. So what does that mean here? I'm going to have 64 plus minus the square root of 64 squared minus 4 times 3 times 80. And all divided by 2 times 3. So let's see what that yields. It's going to go onto my calculator, as you should be doing as well at this point. So I have 64. I'm going to square it, subtract 12 times 80. Okay, and if I take the square root, I get 56. So I have 64 plus or minus 56 all over 6, which becomes what? Let's see here. We're going to have two values. On the one hand, I'll get 20 as an answer. On the other hand, I'll get 10 over 6, which is 5 over 3. So here's a case where we have two values for x that'll give us the geometric sequence we're looking for. And you can pick, well, you have to look at both of them to find the sum of the first 6 terms. So if I pick 20, for example, let's take the first one. So we'll call case 120. So x equals 20. What does that do to our sequence? Well, 20 minus 12 gives us 8. 20 plus 4 gives us 24. And then in the third term, 4 times 20 is 80. 80 minus 8 is 72. And you can see clearly here that you're multiplying by 3 each step of the way. So if I want to find the sum of the first 6 terms as 6, I will get 6 times, common ratio is 3, and that is 6 minus 1 all over 3 minus 1. And once again, pull out your calculators to see what this yields. So I have 3 to the exponent of 6 times 6 divided by 2, so we get 2184. And in the second case, I have x equals 5 over 3, that's correct. And let's see what happens to our values of x. So 5 over 3 minus 12, so for the first one, 5 over 3 minus 12, well, again, I have to get a common fraction here, common denominator, sorry. I get 5 minus 36 over 3, 5 minus 36, and that'll give me negative 31 over 3. So there's my first term. My second term is 5 over 3 plus 4, which gives me 5 plus 12 over 3, which is 17 over 3. And lastly, I have, 4 times 5 over 3 minus 8. So 4 times 5 over 3 minus 8. And that gives me 20 over 3 minus 8, which is 20 minus 24, so negative 4 over 3. So is there a pattern here? Is there a common ratio that we see? Well, let's just take a look. If I use successive terms here and take the ratio of them, so let's do the first two here. So I get negative 31 over 3 divided by, sorry, other way around. I'm going to get 17 over 3 divided by negative 31 over 3. That gives me 17 over negative 31. Similarly for the other one, if I do 4 over 3 divided by 17 over 3, I get negative 4 over 17. Are these the same thing? Well, in your calculator, we can take a look, but I have a feeling that it's not going to be. If I do 17 divided by 31, I get 0.54. If I get 4 divided by 17, I get 0.23. So case 2 actually doesn't work, and our sequence is going to be just with x equals 20.